Let's look explicitly at exponential growth and decay problems. So what we're looking at exponential growth problems of the form y is equal to a times b to the x. And the trick here is that a will be the initial value. If b is between 0 and 1, then this is going to be an exponential decay problem. And if b is greater than 1, this is going to be an exponential growth problem. So if we look at a problem, for example, y is equal to 107, 1.43 to the x, we can answer the question, is it exponential growth or decay, and what is the growth rate? What is the initial value? In this case, 107 is the initial value. And since 1.43 is greater than 1, this is an exponential growth problem. Actually, by writing this in a slightly different form, we can actually read more from this. So let's look at an alternate form. Same function. Let's just rewrite it. Now we're going to write it y is equal to a, 1 plus r to the t. In this case, a again is the initial value. R is going to be the growth rate per time period. And t now is going to be the time period. So you still have a function in y and x, but since x in this case is usually going to be time, we can rewrite it as t. And in that case, you can answer 3 quick questions on any function. Is this a growth or decay problem? What is the growth rate or decay rate? And what is the initial value? So using those 3 questions, let's look at a series of problems. So the first example, let's look at y is equal to 127, 1.41 to the t. In this case, is this growth or decay? Let's look at 1 plus r here. That's 1 plus r in this case is going to be greater than, since 1.41 is greater than 1, this is going to be an exponential growth problem. Now let's look at what the initial value is. The initial value is simply this number right here. So the initial value is equal to 127. Now let's look at the growth rate. The growth rate is going to be the difference between this number and 1. So 1.41 minus 1 is equal to 0.41, so that's your growth rate. So your growth rate here is going to be, you can either say 0.41 or 41% growth rate. And what's great about thinking about exponential functions in this form is you can always easily read off all 3 values. So let's look at another example. Y is equal to 17, 0.62 x. Initial value, 17. Now let's think about what the initial value of 17 means. What we mean is initial value is time is equal to 0. Well, if time is equal to 0, you have y is equal to 17. 0.62 to the 0. 0.62 to the 0 is simply 1. So it's 17 times 1, so it's 17. So in other terms, at time 0, the value of y is 17. At the initial time period, the value is 17. Now let's look at this as growth or decay. We have to look at this number here and see if this number here is greater than 1 or less than 1. In this case, that number is less than 1, so this is exponential decay. And as the last step is we're going to look at the growth or decay rate. So we look at this number, 0.62, and we subtract 1. So if you go 0.62 minus 1, you get a minus 0.38. And you can actually say this two ways. You can either say a growth rate of minus 38%, or you can say a decay rate of 38%. And both of those are quite correct. Or you can say minus 0.38 or 0.38, however you wish. Let's do one more quick example. You have y is equal to 197, 2.35 to the x. The initial value, 197. Growth or decay? Well, 2.35. Is 2.35 greater than 1? It is, so it's exponential growth. Now let's look at the growth rate. It's the difference in this number from 1. So you go 2.35 minus 1 is equal to 1.35. So it's a growth rate of 1.35, which means, let's put that in percentage terms, that's a growth rate of 135%. And that's exponential growth and decay problems.